Okay, so let's talk about database items today. You can just come here if you want, or you can go over there. One is the back, the other one is the front. Okay, so today we'll be talking about database and SQL portion, and let's understand why SQL skill as a QA. Okay. So as you know, I mean, any application, any business application that you are going to work with in the real life, they all include some type of database in the backend. Okay. Whether you are working on a software development projects or data warehousing type of projects, or any kind of mobile apps or any kind of web apps or Windows-based app, they will all have some type of database in the backend. Now, when you are testing through it, as part of the software development projects, these are some of the items that you will encounter for testing purpose. You probably have heard the term backend testing, right? Backend testing is nothing but you are going into the database, verifying the information that everything is populated correctly, everything is saved properly, and so forth. Similarly, data verification is kind of like similar to the backend testing. You're verifying everything is working properly in the backend. Now, most of the big companies like a Nationwide, they have like nightly jobs running, and they do a lot of SQL processing. Okay. So they have thousands of lines of code in SQL, which is getting executed on daily basis at night. It calculates your 401k balance. It calculates your the premium for your policy that you purchased, and so forth. So it's a heavily engaged with the SQL. There is no user interface. It's all about SQL in the backend. Okay. So for that, if you are working on those type of projects, you need to get mastery of SQL, how to execute certain things, how to verify information, how to query the data, and so forth. It's all about SQL at that point. Okay. Now you guys saw some example of the reports. These are operational type of reports, right? And these reports, any web apps or any application, you will always have some type of reporting as part of the application. So if you are testing those type of reports, you need to query the data, compare what is showing on the report versus what's in the database, basically. Okay, so that's where your SQL skill comes in handy. And I think when you are doing the flow, right, certain modules are not ready. If they have only login functionality and lender management, but you don't have dealer management, then when you are testing those, then you have to go and create the dealer or look for the dealers when you are setting up your test data and put it in your test case and so forth. So that's where your SQL skill comes handy. Okay. Now, software development projects typically ranges from $200,000 to $5 million in the IT world or in the real life. There are other kinds of projects which are called data warehousing projects, and their budget is probably $10 million to $50 million. It's all about SQL when you are working on data warehousing type of projects. Okay, and that's where some of the other terminologies comes into play. ETL testing, verification of data transfer from source to targets. We saw one example from system integration perspective yesterday, web services. That is only a small piece. That's a real-time data exchange. But if you are, that occurs when you are doing one transaction at a time. If your credit card information goes in, you are getting the response back in the real time. But when you are talking about migrating thousands and millions of records to another system, that's where this verification of data transfer comes into play. Okay, so those are different types of projects, not the software development projects. What we have focused is here. Our focus in the camp is software development projects. This is a whole other beast. If you want to get into this area, you need to get mastery of SQL. You need to get mastery of some of the understanding of the ETL tools, technologies, and so forth, and get a little bit more technical in that nature. So those type of projects, as I said, 10 million to 50 million, the teams are a lot bigger. You will have a lot bigger teams at that point. And the team size and budget size is much bigger. So you can, and generally this type of projects typically last from 6 months to maybe 2 years, 3 years. This type of projects can last for years, multiple years, like 5 years, 10 years type of thing. Okay. But again, what I'm trying to emphasize is why you need to learn SQL. If you want to grow in your career, if you want to move from here to here, which pays a lot more money as well, because you need a lot more skills in the SQL. You need to get mastery of SQL at some point. But for as a beginner, if you focus on this one, you will be fine. Get hands-on or some understanding of the SQL. And then as you are working through, or if you want to keep on learning, right? That's what IT is all about. You keep on learning, get into this area, and that's provides a lot more job security and everything else. Okay. Any question on this? Why you need to know SQL and the QA? Okay. So today, what we will focus is our focus will be to get you some understanding of basic SQL statements. Okay, basic SQL, and then I'll point you to other areas where you can pick up additional skills, where you can practice a lot more, and so forth. Okay. All right, so let's dive into what is database, because everything starts with the database, right? In the application world. Now, by definition, database is nothing but organized collection of data. That's all we are doing, right? In the Rflow, we have dealer, customer, users information, credit card applications, loan approval, whatever information. But we have to store that in an organized manner in somewhere. And that's where we typically use database. We organize it so that we can easily retrieve the information as well as easily store the information. Okay, so that's where the database are helpful. Now, in the old days, when we did not have database, we used to keep it manually on piece of paper. I don't know whether you guys have seen the yellow files, right? Everybody used to keep it in an organized way, store it. What was the purpose? We can easily find the information when we need it, right? That's the same concept, right? If you guys have seen the TV guide back in 90s, if you are old enough, we used to have TV guide that used to come to our house on a weekly basis so that we can see what programs are on TV. That's all before the internet became widely available. That was in 90s actually, when I was here. Yeah. Then you have all other things yet you are using. I mean, it's some type of database is used in the backend. But so you don't need a computer to have a database. You can store it on piece of paper. That's all the point is here. Now, as things became available internet-wide and databases are available, we started digitizing everything. We started putting in there some type of software. Now, these are some of the activities. It's not all inclusive, but these are some of the things that we do. We use database for like develop reports, sales records, keep track on certain things, and so forth. Same thing, we use it Rflow to keep track of all the loan activities that we are doing. Okay. Now, what do we need for database? Obviously, we will need a software to store the information, right? Which is called Database Management System, DBMS. You will come across that terminology, DBMS, which is a software application which allows you to create as many databases as you want. So you guys install SQL Server, which is a database software, DBMS. You can create 500 databases. If you have 500 applications, you can host it on one SQL Server, all databases. Okay. It's typically installed on one or more servers, right? You guys understand server? Server is nothing but a beefier computer. That's where you are installing so that you have 500 users hitting the database at the same time, it can handle the load. On your machine, you install it, maybe 10 people can access the database at the same time, and it is fine. Okay, on your machine when you install it. But when the number of users goes up, your machine will start crashing. You don't have enough memory and other things. That's why it's installed on a server, somewhere, centralized place. Okay. All right. As I said, you can create as many database as you want for different applications on a same software. Okay, so these are some of the most popular ones, right? So Oracle, DB2, Microsoft SQL Server. SQL Server is from Microsoft. These are top three. The Sybase is also popular, which is also in the market. There are plenty other ones, but these are the main vendors. So most of the companies you will see these four databases, one of these four. Yeah. Now, if you want to run some small applications, which is like 100,000 records or not more than that, then you can have a desktop database. This is how I think most of the people started when the Microsoft Access came in, early 2000s and so forth. They created the databases here on the desktop, where few people can access only, or one person can work on it. Okay. Now, if you have a mobile phone, and I think 90% of these days, any mobile phone that you get, you have SQLite installed. So any application that you install on your machine, on the phone, it will be storing data into SQLite at some point. Okay. So SQLite is built into the mobile applications. And finally, I think you guys can see it here. Let's come back. But it's a MySQL database, which is open source, freely available. These guys, companies pay hundreds of thousands of dollars, okay, for Oracle, SQL Server, and so forth. What you have is a free version. It has same capability. You can create similar databases, but you just cannot handle more than 10 users or 15 users on your machine. That's all it is. Okay? It's exactly, otherwise companies pay hundreds of thousands of dollars for this. So these are all variety of DBMS. Okay. Any question on have you guys heard of any of these terminologies? DBMS database. Okay, so if you have not, I would strongly recommend get a mastery of one of these databases. Okay, at least from the query standpoint and so forth. So we'll be talking about SQL Server. Now this database is a little bit different, but the queries that you will write is pretty standard. So if you learn the query once, you can use it on any database to query the data and so forth. Okay, you don't need to learn different things. Okay, fundamental building blocks of database. Let's see what, when we say now, we'll look at one database, zoom in, and see what is needed for a database. So databases have the tables. So how we organize the information? We create the tables in the backend. Okay, so looking at the Airflow example, we have dealers information, we have dealers, we have lenders, users. So we typically organize them into tables, that information. So dealer record will be created, right? That goes into dealer table. User will be in the users table, lender will be lenders, credit application will have its own table and so forth. This is how you can organize. Now, tables, so that's the structure. This is how you create the structure. And then the data, you will typically have fields and records in the database. Okay, fields are nothing but individual piece of information. So think it this way. Let me take a look at here. So you have this one table, right? This is more like Excel. You have columns and rows. Columns are nothing but the individual fields. Okay, so this guy, so let's say we have a dealer table. Okay, so dealer table has what piece of information we are storing as part of the dealer record? You have a shop ID, right? You have name, address, and all I don't know, I think there are 30 or 40 fields that's with the dealer. So every field has a one column. Okay. So we create the structure, database structure with individual columns, which stores shop ID, name, address, and all those things. Now, when we actually input the values, this becomes our record. So this shop ID here would be, so let me just put it here. So think of it, this is our table. This is shop ID. This is name field. This is address. Okay, so this one record with the shop ID 1, it has a name of Jermaine. Address will be ABC Drive, whatever, and so forth. Second record, if you create a brand new dealer, it will be record number 2. Then you have whatever name you are giving, Honda, right? And then whatever the address is. This is how the information will be stored in a table. Okay, so it's more like Excel. If you work with Excel, then exactly that's what the table will look like. Okay, when we look at the example, I'll show you that. Now, this piece, this one dealer record is obviously a record, right? This is a one record. For item number 2, it is another record. Okay, so it's called record, and this individual piece of information is fields. Okay. Any question on this? Okay. All right. So this is a sample data table for, I think, students, right? So you have ID number, you have last name, first name, street address. This is a student table. You can take it that way. It's a student table. Okay. It's a little bit blurry, but again, essentially, it's trying to say the same thing: records and the columns. Okay. Now, every column that you define is just some type of data type. Okay, so let's go back to our shop ID. I'm just going to use 3 columns, right? This is shop ID. This is name. And this is email. Okay, so I have multiple records here. Now, when you are designing the database, when somebody is designing, not you guys, because you will not design, it's typically the database architect or some senior level developer will design the database while looking at your same requirement that you had. So they generally go through analysis process on the design process. And they will say, okay, what type of information I can store here in the shop ID? What type of information I can store in the name field? What type of information I can store in the email and so forth? Okay, and they will say, okay, this has to be auto-generated. This is a numeric field. So I'm going to assign a data type of number or numeric. This one is a name field. I can put any alphabets in the name. So now I'm going to pull up a data type of char or varchar. It's a character or variable characters. There are multiple differences. Or I can assign text. So difference here, text you can store up to 1 gigabyte of data. 1 gigabyte is like a big giant document. That's the biggest size available. This one you can store up to 1 character to 8,000 character. Okay, in this data type, text string type. So they will pick out different types. So there are various types. Like if you are going to the BMV, they give you driver license, right? But they have to store your picture. So they will create an image data type field, and they will store your image photo right with the record. Okay. Then you have integer and double. Those are numeric data types, specific data types. Double is nothing but decimal. You can store decimal. Integer is a whole numbers only. Okay. So there are different data types available for every column. Okay, so that's what this slide talks about. You can store individual piece of information. It has a data type. Column will always have a data type, some type of data type. Okay, which identifies what type of information you can store in that field. Any question?
So text is only alphabets?
Text is, yeah, it's alphabets basically. But it's a big giant document. You can store the whole documents in the text field. It's up to 1 gigabyte. 1 to 8,000 is more like a 8 KB type of things, which is very small. 1 to 8,000.
So you cannot add numbers when you.
No, alphabets or numbers, anything.
Okay.
Text meaning any character that you want to store. It's pretty much anything you can imagine.
The field should be in the row columns or it can be in the row also.
Which the data types?
Yeah.
So data types are assigned to the columns.
Okay.
Each column will have data type. Records are basically, so records will have, I mean, obviously you will have columns or fields in the records, right? So they will, but the column will have data types, not the record. Okay.
We'll declare it in the column header.
Not the header. So when what happens is, so imagine you are working with the Rflow. So you have Rflow database. This is a database. So every database you will have multiple core tables, right? So you have dealer table, you have lender, and blah blah blah. Okay, all different tables. So now each table you are storing some piece of information. So let's say shop ID. You have name, address, all those fields. Okay, same thing with the lender. You have lender ID, right? You have lender name, address, email, all those things. Now for the field, you are storing some type of information. So you always assign data type to every field. So this field will get a data type. So this is get a numeric or number. This one will have varchar. And you can say how big, maybe 100 character I'm going to allow. Maximum 100 I'm going to store in the name field. Address could be maximum 500, right? So you can put like a varchar data type and allow maximum 500. Okay, so every field you can have this type of data type associated with it. Okay, and when you are inputting the information on the browser, then they will put a restriction. This is where they will put a field length for every field, saying, okay, this database, if you look at in your design, I think design does not include how big the field is, but generally they will include what's the maximum size of the field as well in the design. And then you test against, okay, how big this field will be. Can I put more than 100 character and store it in the name field? Otherwise, system should throw a error right on the screen, basically, and so forth. Does it make sense? Right? Okay.
So what is char, varchar?
Again, they are different data types related to the alphabets. How it basically varies by the size. Okay. Now, char and varchar, right? So there is a char and varchar. Okay. Char I can go up to 1 to 8,000 max. Same thing. This one I can go up to 1,000, 8,000 max. Now, so what's the difference? Because they both do the same thing, right? So when you store the char, let's say I'm storing ABC in a char. So I'm typing in and then I'm saving. Okay. And I'm typing in same thing, ABC and in a varchar. So what the char will do, if the field data type, then let's say this is a name field, we have assigned the char and we allowed up to 500 characters. Okay, name field. So if you put ABC, it will dedicate space for 500 characters right there. So it will put like 500 bytes. It will store as a 500 bytes. Okay. Now in the varchar, when you do that, when you store this, it goes into the field, right? But since it's a 3 character, it will store as a 3 bytes only. So the way it stores is different. Char, you always have a fixed length, no matter what you type in. Varchar, it will truncate it automatically. Okay, and that's why most of the best practice is to use varchar, because it will reduce your space in the database, storage space, and it costs you money, right? Because more storage you buy, more it's going to cost you. So that's why best practice is to use varchar unless you really need char. Okay, but it is available. Okay, that's how they have designed it. You never know when the use case comes for storing, giving it a char, right? Okay. So different data types, no matter what database you look at it, again, they will all support multiple data types, Oracle, SQL Server, doesn't matter. Now they might call it differently. So these are SQL Server terminologies here. Oracle might call, I think integer, double, they might be calling something else, decimal, they might have it, something like that. Okay. Just a different terminology they might use. But otherwise, they will all have different kinds of stuff. Okay, so we started with the database, we looked at table, we look at each individual field. What makes up tables? All different kinds of fields, right? It's a combination of all the fields. And field will always have a data type from that perspective, right? Okay. I think we already looked at it, number, dates, and all those things, so I'm not going to go there. But this is how when you define a table, this is how it will look, okay? When you define a table, when you create a table in the database, so I will have student ID and some type of field type. You will have some type of field length, how big the numbers I can store, or how big the text I can store, and so forth. This is an example of data dictionary. Okay.
What is the primary key?
We'll talk shortly, but best practice is every table needs to have at least one primary key. Okay. And the primary key is the one that uniquely identifies every record in the table. Uniquely identifies every record. So it does not repeat. So it's a unique, something unique about that particular record. That's what you mark it as a primary key. So imagine, I mean, if you have thousands of students with the same last name, first name, and you don't know how you can retrieve the information or identify and distinguish between them, right? So what they do is they typically assign a student ID, which is unique to that particular student. So as soon as he comes at the desk and say, oh, what is your student ID? And they can pull up his record. Okay. So it's like we all got a social security number, which identifies everybody uniquely, which is unique for all of us, right?
So you said primary key is unique, but here for last 2 rows, it's no, the same.
Yes, because only primary key is unique, right? It can identify the record uniquely. It never repeats the value. This column, if I create thousands of students, it will start from 1, 2, 3, 4, 5, 6, but it will never repeat same number for different students. Same thing, social security will never repeat for individually for all of us, right? Now, what this says is primary key, it is marked as primary key, no. That means it can repeat. I could have 2 John Smith in the database or 50 John Smith, doesn't matter.
Yeah.
As long as they have a unique number, which is and that's why you will see auto number, right? Auto numbers, I think in Athlon, we have so many auto numbers in different tables.
Yeah.
That's what it is. They are marked as primary key. Okay. All right. Any other thing? Okay. All right. So there are different types of databases. Okay. But in most of the applications, you will come across the database, which is a relational database. It's a relational database, RDBMS. So DBMS, right? We talked about DBMS, database management system software. When you say RDBMS, which is a relational database management software. So SQL Server, Oracle, they all are RDBMS. Okay. I have uploaded a slide a little bit. So I'll upload the slide, right, in the shared folder, you can get it. But I think you have more information that what I have on the slide. Okay, it's there somewhere for you. Okay, but this is relational database table. So let's make understand the definition of what is called relational, right? So tables are connected or related. So we all have relationships, right? We are connected type of thing, right? Or everybody via, but in the database terminology, tables are connected via fields within the table that are shared by a pair of tables. Again, definitions, they always make it complex, right? So let's see what it means. So I'm going to show you one example here. So I have a dealer table. And user table. So there are users that are marked as a dealer user, right? Now, how do I know they belong to certain dealer? Now in this example, let's say we have a shop ID that is a primary key for a dealer table, and user as a user ID. Okay, some type of unique identifier. They might have other fields as well. We don't care about those. Now, what the definition said, tables are connected via fields within the table that are shared by a pair of tables. So if I want to make this, if I want to say this user belongs to this particular dealer, German dealer, then what the best practice or what the design practice is, you carry the shop ID to the user table and store it along with the user record. Okay. So now this field belongs to users table now. This field belongs to shop ID table. It's a common field. Okay. So now I can say dealer table, I can show the relationship here and say dealer and user tables are related because they have shop ID belongs to both tables. Okay, and I'll go through the ER diagram, ER model shortly, which will explain you a little bit further. But essentially, you are carrying over the primary key of one table into another table to make it relational. That's the whole concept here. So I can carry the dealer table, primary key, which is shop ID, and I will put it in the user table. I can store it along with the user record to identify this particular user XYZ, which has a shop ID 1. This dealer table has a shop ID 1, which is for German Toyota. So I can relate those two tables. That is a concept. Okay, so don't go again, common columns. That's just remember that for now to make it relational. Okay, I think we'll see a few examples as well, a little bit. Now, how do we come up with all this design and all those things, right? So how do I know which table is related to what and all kind of stuff? So that's where the concept of data modeling comes into play, which is a design process. And I think if you go to Columbus State Community College, they have one class, one semester they spend on design only. Okay, just a design. They will not even give you a tool. They just say, okay, you need to understand design. How do you analyze the things and come up with the database design? Okay, and as I said, you will not be doing it, those design process, because you are quality assurance. You are not a database developer or architect. Okay, but database design is the first step, and it's a progression from conceptual model to logical to the physical database design. Schema is nothing but a design. Okay, so that's the process they follow. They draw out the concept, right? That's how everything starts. I guess Elon Musk came out with a concept car on piece of paper. Then they refined that model to make it actually look like maybe they did computer modeling, whatever, put some design, best practices and so forth. They came up with the logical design of the car. And when they implemented the actual, when they created first car, probably it was called the physical. They might have refined the logical model a little bit further when they actually build the car, first car. Okay, so it's just That process is same in any industry. Look, conceptual, you start with the conceptual modeling, then you go to logical and then the physical. Physical is the one that you actually implement in the database. That becomes your database design. Okay, so what you had in the Airflow design document is more similar to the physical model. Now, if you don't see primary key defined and other things, primary key defined, or if you don't see like lengths and those things identified, then you can call it a more like a logical model. So what you have in the design is more like a logical. There might be another design document which is a physical when they actually implement it. Hey, this is a primary key. This field has to be 50 character and so forth. Okay. So that's the process they follow. Okay. I'm not going to go much detail. I'm just going to give you conceptually, but there are certain rules they follow as part of the process. You might hear the terminology once you get into IP, like a first normal form design, second normal form design, they can go up to fifth normal form design. So those are the design processes. Okay, but essentially, what they want to make the database more flexible, and they want to eliminate storing the redundant data across the tables, basically. Okay, that's all essentially it says. And then that's what it is, organizing data in the database. That's the process. They will follow the process step by step. Okay, so let me move on from there. Now, as part of the design process, they will come up with this is more of a logical model. It explains how the entities are related. Okay. Now, why you need to understand that? Because without understanding this type of diagrams, you cannot write your queries, complex query. You can write the simple queries, but you need to understand. And this is what they will give you. Okay, if they expect you to write queries as a QA, you need to ask for, hey, give me the diagram that explain me how the database tables are related. And this one can explain, this is one of the things that can explain you how the tables are related. Okay. So here I have product table, ordered line table, order table, customer table. This is a different types of. For Airflow, you guys saw it, right? We had something similar to this one in the design document, right? There's some relationship and so forth. Okay. So this is a one type of diagram. Okay. Now let me talk about a couple of notations here because you need to interpret what those are. So here, there's a notation here, this particular line here, right? This is a notation. This shows a relationship. What type of relationship is between the product and order line? What type of relationship between customer and order? Okay, so this line shows the relationship. Okay, let me explain you what those notations are. I think it's in your binder as well, but I'm just going to explain you. I'm just going to put the common one here. Okay, so this relationship explains, it doesn't show here, but I'm just going to put that. This relationship, right? It says it's a one-to-many relationship. Okay, one-to-many. So when you are reading it here, relationship between customer and order. So the way you can interpret is one customer places many order. Okay, this is this one is many. This symbol. So one customer places many orders, one or many orders, right? Yeah, that's how they are depicted relationship. Now, same thing, one product belongs to one or many order line. So if you look at your grocery bill, right? you will have, this is a model for the retail items. So what if you are a customer, you can place one or many orders, right? Your order will contain one or many product. So one order number, you will see it. If you have like a Meyer bill, look at it. It will have one order number. You have line items, right? And that contains, those are nothing but multiple products. But line item has a unique number as well. They will assign 1, 2, 3, 4 or XYZ, whatever they have meaning. But essentially, product in order is part of the order line here. Okay, that's what it shows. So we are talking about one to many, right? Here. Now this symbol is many to many. So if I change this side, something like this. So what it would say? Customer places many order belongs to more than one customer. Is that true for real life? Specifically the grocery, it's not, right? Because you are the one buying, you are the one customer. But in certain scenarios, if you are buying, 5 people are buying the same item, they put 5 people's name, maybe your mortgage or your house name. So you can say house belongs to many owned by many people, something like that. Okay. Now, if I say this one, only this symbol. So one customer places only one order, right? You cannot have customer with more than one order. That's what the notation says. Again, there are different use cases, basically for different notations, but these are the most common one. One to many, many to many, and one to one. Those are the 3 common ones. Okay. And we will take a look at it in the R flow, what we have, so that it makes it a little bit more clear. Okay. So as I said, right? So you have database design. Sometimes they represent the ER models, something like this. So this one you can consider as a logical model, which does not have primary keys or anything else, right? Here, it shows the relationship. Now, once they come up with the physical model, you will actually have primary keys identified for every table and so forth. So they will start with the conceptual, they will come up with the logical, and then they will apply the design principles or normalization principles and come up with the physical design. This is what they will implement. So here, I have a chapter ID, I have book tables, chapter ID, chapter table, right? Book table has a primary key of book ID. Chapter table has a primary key of chapter ID. Now, in order to relate these 2 tables, because book might have many chapters, right? So in order to relate this, book ID is also stored along with the chapter. That's what it makes it. That's why I can write some queries and I can find out, okay, how many chapters I have in this book. I can answer that. If I don't have book ID, can I tell? I mean, I cannot relate. Okay, these two tables. Okay, so they put the book ID here. So you see the primary key symbol here, which is a PK. Now there is a FK symbol. So when you carry the book ID to the child or related table, right? So it belongs to this table now, book ID. So in the chapter table, this column, which points here, is called a foreign key. So primary key, foreign key relationship. It's always going to be primary key and foreign key relationship. Primary key is book ID. In this table, primary key is chapter ID. But the book ID in the chapter table, which points to the book table, is called a foreign key in the table. Okay. So primary key and foreign key, they go together. Okay, most 99% of the time. Once you carry the one column in the second table, it becomes you can call it as a foreign key, which points to the master table or whatever, parent table or child table, something like that. You can think it that way. Now in the relational database, right? All the tables have relationship with one or more tables, okay? Using the primary key and foreign keys. Okay, the book table might be related to some other table as well. Book might have book details or what are the actual things. So that table, you can carry the book ID in that table, you can relate that. So primary key, so each table will have at least one primary key, but you can have more than one foreign key in the table because this table might be related to 5 different tables. Okay. Any question on the primary key, foreign key concept? Okay. So I think I already talked about the 3 types of relationships, right? One-to-one, one-to-many, many-to-many. It's already there. So I'm gonna skip that part. Okay, let's take a look at here, this particular example. So I have 2 tables, right? Department table and instructor table. Now, are they table related? Is there relationship established? Which table has a primary key? Department number, right? Now, even though you see the different column names, right? Column name doesn't have to be same. Okay, when you are creating a field here along with the instructor, you can name it differently. But what the database DBAs or administrators do, they will create a primary key, foreign key relationship. There is a special thing they can do, which will point this field to this field when they create the different tables. Okay, so
I have a question.
yeah.
Like it's similar to, it's like what I understood is similar to Excel. When we create a link and I click this, I have to go there, like kind of.
It is similar to Excel, but here it's a relational database, right?
Yeah.
So yeah,
It's a kind of.
so if you update in the link, whatever the link table, link field, then it will also update the other field,
Yes,
right?
yeah.
It doesn't work that way here. If you update department number here, that doesn't mean it will change in the here. Or if you change it here, that doesn't mean you have to enforce, build the code yourself, set the rules, which are called primary key, foreign key rules. You can set those rules. If you update the department C to department D tomorrow, then it will go and automatically update here. But those are the enforced manually, not automatically. Okay, so you have to build some logic around it. But it's a similar thing, you know, this is like a relating, right? Information. So, yeah. Okay, so if I have to find out all the instructor who belongs to this particular department, I can easily do that because the department number is there. And I can find out what department name or location they are working, basically. Right, because department number is here. So when I write my queries, I can pull up the data from these 2 tables. Otherwise, I cannot if department number is not there. So again, relationship joining 2 tables on a common field. That's what.
Okay, department number is primary key.
Department number is primary key in this table.
Foreign key.
Foreign key is here, right? Because you are carrying this department number into instructor table. So in the instructor table, department number is called a foreign key, which points to the department table. Right? But instructor table has its own primary key, which is instructor number. Okay. Any other question? Okay. All right, so in the relational database, there are some rules, right? As I said, I mean, you must have a primary key, right? Which is a uniquely identifies every record in the table. Must have no duplicate rows. Obviously, you have primary key, which is unique, so it will never create a duplicate rows in there. And the primary key is a data attribute or combination of attributes that uniquely identifies each record. Now, So what it says here, I can have more than one field as part of my primary key. Okay, so it's not a one field. So auto number, unique student ID, if you create and assign auto number, it will guarantee that it will be unique. But in our example, let's say I have just first name, last name, and date of birth. So first name, last name, and DOB. And I have John Smith, 1/1/2000. John Smith, 2/1/2000. Can I create a primary key? I don't have any unique ID assigned, right? But what I can do is I can create a primary key on these three combination, which identifies the record uniquely in this table. So I can create all three field combination as a primary key. You can do that. It's not a best practice, but you can still do it. You can mark this combination of three fields as a part of the primary key.
Primary keys are ID.
No, here in this field, we don't have ID. So what you can do is, you can create a combination of fields and mark it as a primary key. Your goal is to identify the record uniquely, right? That's all it is. So I don't have any other fields. Assume there are only three fields. I can mark all three fields as a combination. Okay, so the primary key definition, it's a data attribute, single column or multiple column, combination of attributes, multiple column that uniquely identifies each record in the table. Okay. Now, if you have just simple key, simple primary key or simple key, you can have composite primary key or composite key. So here in this case, this is a composite primary key. Okay. Composite is nothing but more than one column, which is marked as a primary key. Simple key is a single column. So previous example, when we looked at the student ID, it's a simple key. Okay, simple primary key. Again, the whole goal is identify the record uniquely. So you use one field as a primary key or multiple fields, doesn't matter. Okay. In normalization, we use normalization to help identify primary key for the table. Okay. We already looked at foreign key, right? What is a foreign key? Oh, foreign key is nothing but a key that points to a primary key in different tables, right? Okay, so why do we do the database design process? So let's say you have this Excel spreadsheet, right? Now look at the information here. Let's say you have just Excel spreadsheet. Now you have John, this guy, student ID John A121, right? It has this information being repeated 5 times, right? Similarly, he has phone number, this thing. What is the goal of the database design? To minimize the redundant information. Okay, so I'm repeating the information. If I retrieve the record, I'm gonna get 5 records with 5 different things. If I update anything, I have to update 5 records here. Let's say his address changes, he moved to different apartment. Now I need to worry about changing all this information for him. Okay, so that's the reason you want to go through normalization process and design the database so that you update only one record or minimize the redundancy and so forth. So if I take this normalization, this database and convert to the relational database, I will have 6 different tables. I apply all the design rules. So I will have student table, I will have class table, teaching assignment, enroll table, instructor table. Just when I convert this guy, so it will increase number of tables significantly. But it will be a lot faster to retrieve the data, update the data, and so forth. Okay, so that's why you go through the design process. Okay. All right. Okay, any question here? So far, we talked about only database side of things. We haven't really talked about anything else.
Here, the student ID will be the primary key and.
So student ID is a primary key of student table.
And then course ID will be the.
Course ID is a primary key of class table.
Okay.
Course ID is also here teaching assignment, right? So there might be a combination of the keys. It might be a combination of term and course ID.
What will be the foreign key here?
So this course ID, see, there is class table is shown. There is no relationship between course and class student. This table here, enroll table.
Yeah,
This is this table relates here everywhere, right?
yeah.
Course table here, instructor. This is the one that says which student is enrolled in what course, right? So there is a relationship between class. So it's a one to many type of relationship. Same thing, one student can enroll in many course, right? One or many course. Teaching assignment. So instructor, I don't see it here, but I think there is an instructor table here, instructor ID. Right? Instructor ID. So you can relate to one instructor can teach many courses. So that's why you can identify who is teaching what as well. Okay. So the student ID points to this student table. So this is a foreign key. This guy course ID points to class table, which is a foreign key, right? In this table. So there are multiple foreign keys in the enroll table, which points to multiple tables.
So the same student ID can be primary key in the first table, but it can be the A1 to 1 we declared as a primary key in the first table. Right?
In the student table, this is considered always a primary key.
Okay, but here in this table, it's considered as a
Foreign key. Now, what is a primary key then in the enroll table? Right? What would be the primary key in the enroll table? The whole goal is to identify enrollment record uniquely, right? Who is enrolled, what course they are enrolled with, right? So you can mark it as a combination of those two as a primary key. Okay, because that does not repeat. A121, MIS 350, A121, MIS 372, and so forth. So it's a composite primary key. It's a primary key, but type composite because multiple fields are involved. Other tables has a simple key, simple primary key, which is single field. Student ID, course ID, instructor ID, and so forth. Okay. All right. Any other question? So these are database concepts. Okay, primary key, foreign key. I think these are interview question as well. If you put SQL on your resume, which you should, that will increase your market value. But you understand this concept and you can explain them. This is what the primary key is. This is what the foreign key is. They're not going to go a lot more detail in the design because they don't expect you to know how you come up with. But if you know one to many, many to many, what it is, you can maybe explain with the example of R-flow or something. Okay. All right. So let's talk about the SQL side of things, because that's what the work is, right? That's where your work starts. So far, we have talked about some basic concepts. Okay, so let me just get you overview, and then we'll dive into the PowerPoint slides. I think 4 or 5 PowerPoint slides I will cover. But SQL is nothing but a structured query language. Okay, it's called structured query language. Now imagine what are the activities that you are doing. So we have R-flow database. What are the activities that you are doing with the database as a user? Remember, you guys did this CRUD. What is the full definition of CRUD?
Create,
Update and delete.
update and delete.
So there are potentially 4 possible actions possible with the database. When you say create, am I creating something new? When I do read, can I pull the information out of the database? Update means, can I update existing? Can I delete anything? Right? So create, Read meaning you are pulling the information. Update is you are updating something. Delete is you are taking delete action. So 3 arrows going in, 1 arrow is coming, 1 arrow is coming out, right? So those are CRUD activities with the database. Okay. So in the SQL, in order to support these 4 activities, CRUD, you have different statements. For create, you have an insert statement in the select or insert command. For update is very straightforward. Update is update command. For delete, it's a delete command. So update and delete are same. Activities wise, CRUD is based on CRUD. And for read is a select. So there are potentially 4 activities you can do, and there are 4 SQL commands. So you need to master these 4 commands, or potentially select command is the most important for QA. Okay, most important for QA. 90% of your SQL activity will be with the select. Okay, so whatever you do as part of your testing, 90% of the activities you will spend on select command. Update, delete, you will never do it. Maybe 1%. How about never means never? So let's put 1%. But this to update and delete, I think insert is more like 5% of the activities. Update is a little bit less, maybe 4% of the time. Okay. So if you spend a lot of time on select, this is where we'll get you a lot more question and answers. You will get it. Insert, update, and delete. They are very straightforward commands, and you can play around, and I'll show you how easy they are. But this is where you're gonna spend most of your time as a QA. Okay.
So who uses most update and delete and insert?
The developers, because they have to put there's create when you say save, somebody has to write the code to actually save the information. So developers will spend a lot more time. But if you are going in the automation route, what you guys do typically is you write the scripts. You wipe out the database before you run the automation test. And when the test is done, you will again wipe out basically. But you need to populate certain things, like populate your test data so that your automation test works. So that's where you write insert and update commands. Okay, as part of your scripts. But otherwise, select is the one. If you are manually testing, then you will spend most of the time on select. Okay, unless you are creating the test data directly in the SQL. Okay, so I just wanted to give you a little bit perspective of where you will spend most of the time. So let's see what those some of these commands are. Okay, so pronouns is SQL, right? SQL. It's a standard set of commands for dealing with the relational database activity. Okay. Use specifically for query retrieval, includes command for defining the. Now you will never work as a QA for creating the database tables. There are another set of SQL commands, but you will never do that. Like create database, how you can create database in a SQL, how you can create table, how you can define the rules. Those are done by the developers or database administrator and so forth. Okay. Okay. Now, relational database varies, right? SQL to Oracle, they might have some variation, but as I said, it's a standard set of commands. So you can, once you learn once, you can apply on any database with a little bit different syntax maybe, but otherwise concept remains same. So since you're gonna spend most of the time on select, we'll spend some time on select. Okay. So select is a command. It's a command. So when you are talking about programming, right now you are talking about programming world. So you have to follow certain rules. Okay, follow the certain rules. So let me come here. Let me show you the actually end command. See if I have it. All right. Okay, I don't have it here. But essentially, I wanted to show you what it looks like. Okay. So this is the nomenclature. So this is what it will have. So select. Select, and then you have list of fields. Okay. Then from what table? Then you have a table name. Okay, and then you have some filter condition. Where some filter condition. And then you have order by sort condition. So this is a very basic syntax. This is the full command. Well, there are other things as well, but I'm just giving you what you will be doing most of the time. So select what fields you want to pull from the database table, or basically. So you want to list out the fields. Then you will have from what table. Okay. So if you want to pull out from dealers, you will say from dealer, basically. Then you will have some where condition, because there could be millions of records. You don't want to pull out all million records. You are interested in one record, then you have to specify some filter condition. Filter condition you have to specify in the where clause. Okay, and it says where SOP ID equals 1. So I'm interested in SOP ID 1 record only. Okay, and this is last one is if we are pulling 10 records, then you can say how they should be sorted, how they should be displayed. So that is what the order by, and you can say order by SOP ID ascending or descending. So starting with smaller to higher or higher to smaller number. So these are 4 basic things, okay, that you will find in the select statement. There are some variations. I'm not going to talk about complex things here, but if you want to pull from multiple tables, you have to apply the inner join, left join, and so forth. Okay, but we're not going to go much detail. I'll show you one example on that, and I'll point you in different things. Okay, but let's see, focus on this 4. So let's come back. Okay, so here, right? So I'm in the select command. So if I want the last name and first name, right, from one of the tables, then I will say select last name, comma, first name. Okay. Then what I said is what table, you need to specify which table the data should be coming out. So you will say from student in our example here. Okay. So this is what our command will look like. Select last name, first name from student. And if I run this query, it will work because you need to have select and from. Those are the minimum 2 things you need to have. You don't need to have where clause or order by or anything. Okay. Then the query will run and it will pull all the students. And so is last name and first name. Okay. Now, these column names are the field names. Okay, that's you need to know what field names are there in the table so that you can use it in the query. It's not a random name. I cannot just type in last name or first name. Okay, has to match with the table fields. Okay, now where condition. So as I said, it's a filter condition. You can limit the number of records being written if you specify the where clause. So field, this is a syntax. Select whatever fields from table where, and then you have Boolean expression. So I said SOP ID equals 1. So as long as SOP ID equals 1 exists in the database, it will pull that information because it's a Boolean. Where anywhere that condition is matched, it will pull the information. I can say where dealer name like German. If there are 2 Germans, it will pull both Germans. Okay, but this is the format. So in this example, right? So this is a textbooks, this is the query. So select star from textbooks where category equals computers. So what it will pull? So it will apply filter on this category field. Wherever is computer, it will return in the results. Okay, select star. Star meaning all the columns. So I'm not saying specifically title, give me title, comma, price. I can say select star, it will return all the columns. Okay, all the fields from the table. So it will return wherever the computers, this condition is true, it will return those records. Any question on this one? You can understand conceptually?
If you are using the where command, so the filtration condition is going to be in quotation.
Yes, because it's a string, right? So you're matching with a string value. This is probably data type as a varchar, char, or text. So you have to specify in the quotation that condition. Now, if you are matching with the price or maybe some numeric value, you don't have to specify in the quotation.
So it's only for string.
Yes, it's for the strings. Yes,
Okay, thank you.
type or something like that, not the numeric value. Okay. Okay, so let's take a look at one more example. So here I'm picking out 3 fields. Select title, price, publisher from textbooks where price is less than 110. Again, this is a Boolean expression, right? Anywhere the records are being matched from the table, then it will return. So it will first apply the filter. Filter condition will be applied. 109, so I just need to see it manually scan it. 83 will come out, 109.99 will come out, right? So I should expect to see Java 109 and whatever the publisher, practice all. It will not show the category because I have not selected here. Okay. Right, so here those 2 things will be shown, right? So, so those are, so far we've been dealing with the single table, right? But that's not how the real life works. You need to pull the information from maybe 5 tables, maybe 10 tables in a single query. Okay, that's where the join comes in the play. Okay, so join is always between 2 tables. Even though you need to pull the information from 5 tables, join is always between 2 people, right? The same concept. You need to join the 2 tables and then create a chain of joins to for other tables. Okay, let me show you, see if I have example here. So here, did I say the course text? Okay. All right, I don't think, well, let's see if I have example in the back. Otherwise, I'll show you in the SQL. Okay, so here in this query, I have created, I'm pulling information from 2 tables here. So I have textbooks and course text. Okay, so select textbooks.title. Now, when you are involving multiple tables, the best practice is you write the table name dot field name. Okay, that's the best practice, so that you know which table the field is coming from. Okay, so textbooks.title, price required from textbooks, inner join course text on. Now you need to remember the relationship concept. What is the concept for relationship? What has to be true in order to relate the tables? Can anybody tell me? What has to be true?
Primary.
And foreign key, right? The key needs to exist in both tables. Now you can see the value of that foreign key, primary key, because I can join that, create a join based on that common key. So what I'm saying is inner join. So join these textbooks with the course text, when I say inner join on textbooks.title equals course text.title, because title exists in both tables. So I can join on this field and pull up the information from both tables. Okay,
Can you go back to the table? The table which says the name.
let's see here. This is a table,
Okay, but the textbook doesn't have,
title.
no, like the query which you have shown, like for the join.
Yeah,
The course text.
The something is not there, the rep.
there is a title. All it cares about for join is, do I have a same column in both
The
tables?
required field is in course text.
Okay,
Should
let's
we
see.
be declaring that in the select?
Required is not shown here, but it's here.
Yeah, but when you select, we are selecting only the textbook, not the, for the required thing. We
Oh,
have
so you can say textbooks.title.
price, but the required is in the course text.
Yes, so what you need to do is,
I have to declare that too. Right?
yeah, so generally, when the field belongs to both tables,
Uh-huh,
SQL gets confused.
uh-huh.
Okay, it doesn't know to which table the title is coming from when you put it in the select statement or anywhere. That's the reason you need to specify textbooks.title, because I'm pulling the title from textbooks. I could have done that from the course text as well, because title exists in that table as well.
So, my question is required is in the course text. It's
Yes,
not in
yes.
the textbook.
But
How does it know? that?
yeah, so remember, this field belongs to course text only.
Hmm.
Required. Course belongs to course text only. Price belongs to textbooks only. It does not exist in both tables. Okay, but title belongs to both tables. The best practice is you always specify when you have multiple tables. You say textbooks.title, comma, textbook.price, comma, course text
Yeah,
dot,
that's what I'm asking.
category.
It's not over there.
which is fine, it will still work.
Mhm.
Because SQL will not get confused, because these are unique names. All course belongs to only course text table. Or price belong to only textbooks table, right? But title belongs to both tables, so SQL doesn't know which table you are talking about, because it belongs in both tables in that query. Okay. I mean, I could have easily wrote textbooks.price and course text dot required, which is perfectly fine. It will still, query will still return you result.
So.
But
can
these
we-
fields are unique in both tables. It does not exist in both tables. That's why SQL will still run.
So from textbooks, comma, can we put the, or whatever?
Textbooks
Course
dot
text.
title, comma.
From textbooks, comma, can we add that table title over there?
Yeah, you can, you can put, again, you have to type in textbooks
Comma,
dot price, comma, course text dot required. Okay, this one you can get rid of it. But it will, the query will still work with this one, okay?
okay.
Because they are unique field names. It does not exist in both tables. Both tables meaning textbooks table and course text in our context of the SQL. Okay, but this is a best practice. Yes, this you should always follow this one, just to avoid any confusion and anything, and so forth.
Like, instead of putting interjoin, can we join textbooks and core text in one?
You can, but that's not the standard. Okay. I mean, you certain, you can run it on SQL, maybe on Oracle, but it may not work on Sybase because it's not following the standard. Okay, but this is the way, this is the standard way, so that your query doesn't break, and so forth. Okay, so from textbooks, inner join course text. Now I understand you might have printout which has that different syntax, but we changed the syntax. That's why we updated the certain slide, because it wasn't appropriate syntax. Okay, I mean, it will still work if you don't have a join condition, right? If you just say comma course text, but it's not a standard. Okay, it will still work. So that's why I have uploaded. I think I have uploaded already, or if not, I'll upload this slide so that you have the latest slide. Okay, so this part will join the two tables and then you have the category computers. So if I come here. And this, when it runs, it will return two results. Okay. As I said, you're gonna need the joins in order to pull the information from multiple tables. And the only way you can understand how to write the join is because if you have the ER model, so that you can know which tables are related to what other table. Okay, that's why you need to understand the ER model. Okay. All right, any questions so far what we talked about? All right, let's dive into the actual I'll let you guys work through some exercises here so that you get some practice. I think we'll go till probably 11:15. We have 45 minutes, and then you can work through at home. Okay, but let me just quickly set you guys up and just get you guys started. So now you can open up the Management Studio. But you don't have SQL Server Management Studio?
The one that we downloaded last fall.
No, you have SQL Server Management Studio. You should have installed it, right? At home?
Huh.
I don't know, that's my system.
Okay, I'll get you another computer. You don't have SSMS, right? Just search for SSMS. Okay, and open that up.
Process that keeps failing.
Oh, is it? You don't need to open that up. You just type it in here, SSMS. Okay, in the Windows. You don't need run those installation again. Okay, don't run the SQL Server installation again.